And welcome to my Internet Programming and Internet of Things Project 4 video, which is about the backend implementation. Now, again, this is airpollute.io. It is an air quality monitoring website application. And for this phase, we will be using the CouchDB database to store our information. So again, as we see here, this is our home page, and you can log in and sign up. For instance, so these username and password already exist in the database users, and they will be checked to see whether they match the username and password that are stored over there, and it will allow you to sign in. Otherwise, you would have to create an account in which you have to enter your email address, first name, last name, username, password, etc., and sign up, and it will create an entire new user in the user's database. But other than that, so we will enter the username and password, and it will take us to the About page, which again shows you some information about the product and what are the variables that we are measuring. Now, after that, the toolbar will expand and will allow you to have a simple, detailed, and map view. The simple view will show you in your current location. For instance, now I'm in the American University of Sharjah, and it knows this through the longitude and latitude view in our database, in which we store all the coordinates of the locations in which we place our midpoint nodes that have the sensors that measure these pollutants. So for instance, for my current location, it's showing me the concentrations of carbon monoxide, nitrogen dioxide, and dust. And the width of these pollutants are set by a mathematical formula that we have developed that allows us to establish the severity of the concentrations of the pollutions and color code it as well. So for instance, here you see the green color and the message below it signify that it is safe. The red signifies that it is dangerous, and the orangish yellow color signifies that it is medium in terms of danger. And again, the width is set dynamically through parsing the JSON object that is received from the database. Yes. As for the detailed view, and now here you have to select the city that you want. So each city has different locations that measure the air pollution, just so we can show an example of how it can be implemented for different cities. For instance, if you want Sharjah, so here you can see the Sharjah weekly air pollution. So the first one is Sharjah 1. It could be anything like the AUS campus. Sharjah 2 can be the University of Sharjah campus, etc. And as you can see here, you can see the concentrations of carbon monoxide, dust, and nitrogen dioxide across a daily spectrum. And you can even trace all the values, as can be seen here. Again, once that's done, you can go to Dubai 1 and check it. Or you can go to the Ras Al Khaimah 1 and check it as well. You can also press the buttons to go there directly. Now, lastly, we have the map view, and it will show you the locations of the safe midpoint nodes. And for instance, here, again, it will use the longitude latitude view from the database, and it will parse the object so that it can be the object that Google Maps API uses. So it has the longitude and the latitude. So we kind of get both these values, and we instantiate an object so that it can be shown right here. And for instance, here it can be shown that we have an air monitoring system at American University of Sharjah and one at University of Sharjah. And if we zoom out, we have some here as well in Academic City, and it just shows how they can be used for different in different regions, and how if we can populate these systems, it'll be really easy for the user to know where is the safest region that is next to them, in terms of air quality. Now, one more thing that I have missed is in terms of the simple one. So here it checks the database, and we have in terms of carbon monoxide, we have a view called carbon monoxide view, a nitrogen dioxide view, and dust view. And these, so in each location, it takes multiple readings, and we take an average of that reading by using the reduce function. And for each location, it shows us the average of carbon monoxide, nitrogen dioxide, and dust reading. And this is what we're getting right now. So for multiple readings, we're getting an average, and then we're displaying it for each location, because the database, the view is set by the location name. So charger 1, charger 2, charger 3, etc., followed by the 3 gases. And finally, we have the sign out option, which just takes you back to the home page. And yes, we are using the CouchDB, and we are hosting our website on a server. And the watch will be continued right now. As for the watch, as you can see, the first thing that gets displayed is the logo. And once you start interacting with the watch, for example, scrolling the bezel, you will begin to see the status of the pollutants. For instance, carbon monoxide, dust, and nitrogen dioxide. And both the status and the circle around it is colored depending on the severity of the concentration of the pollution. In addition, you'll be able to get an alert from the watch to check your phone for the nearest safe checkpoint if the concentrations of all of them tended to be on the dangerous side. And of course, you get all of their values from the databases displayed, so you can check a summary of all the concentrations of the pollutants. You can also scroll anti-clockwise. So each state is saved. Also, if you're in a safe environment, it will let you know, such as this. And that is it for the watch.